Yeah, Cynthia. The mic.
So if I'm a company and I want to have my ad be really successful, is there some way I can manipulate the system to try and get my ad, have a very high click rate and not pay so much for my ad? There's some. Because right now it's auctions, right? So the companies have to.
Right, so I think the name of the game on that one is to fake the outcomes. I mean, there are 100 million ways how to fake clicks, from paying people in third world countries to do it for you, over technical solutions to do that. So in terms of gaming the auction, I haven't seen a lot there. I mean, there are people who have strategies like, it's called carpet bombing. You always bid 1 cent, and once in a while you get lucky. So there are attempts to just spread it wide instead of going really targeting specific people that you consider high value, just try to reach everybody. And it's related to the incentive system of last touch attribution, that may actually be a good strategy. I don't see the auctions being gamed otherwise directly. It's more the strategies around how to bid or just faking it entirely.
You can always optimize the landing page to some extent to make it more competitive, right?
I think that's a question too, but here the point was, if I'm who I am and I have no access to the landing page whatsoever, how do I make myself look good, if I understood your question right? It's a different question on what to do if you're in a different position, but I haven't thought about that.
Yes, I have a quick question. So isn't it sometimes that you could be actually predicting the people for the ads that are already going to buy the product? And how can you tell that actually the ad helped and not that you just predicted the people that were going to buy it anyways?
Are you asking me whether...
So you look at the patterns, probably the website they went to and some of the things they did. That could be the actions that you're following are people that already are on the path of buying the product. So the ad you're not predicting that people that you're going to push them to buy.
Absolutely. I mean, the reality is I'm not incentivized to find people to push. I'm incentivized to find people who buy. That's what I'm paid for. Once in a while, somebody runs a Nielsen study to evaluate whether or not I push people. My suspicion is that Nielsen is in business because they more often than not say, yes, they got pushed.
Okay.
I mean, I've seen reports where we look stellar, and I don't believe it for 1 second that we had as much influence as it seems to have been. But your observation is very, very true. Yes, my incentives are measured on conversion rate, not on incremental conversion rate, because most people have a hard time assessing that. So I'm trying to find conversion rates, not influencing people.
I guess my question is for Claudia. I guess it's still unclear to me, how much better has this ad tech technology and algorithms, how much better has it made click-through rates in the past few years in terms of converting people to websites and then to consumers, to customers in general?
You're asking how much better the modeling is over not modeling is?
Yeah, I guess I'm wondering, just the past few years of,
okay.
And what's been the increase of return, I guess.
I think that when it comes to esoteric hobbies like scrapbooking, my ability to predict who is likely to buy material for scrapbooking is huge compared to random, because there's so many people who don't. So in terms of lift, there are these exotic small things where if I get any signal, like the fact that you read this article or this blog about scrapbooking, it's an amazingly good indicator of doing that. So there are certain very predictive problems. There are certain things where I can get an AUC of 0.98 on predicting whether or not somebody goes to buy scrapbooking material. There are other problems like applying for credit cards. Everybody and your grandmother is trying to get a credit card. there is no signature of that personality, and predicting that kind of behavior is much, much harder. In general, stuff that a lot of people buy, it's much harder to predict than stuff that very, very few people buy. So I think the tooling we have for some things are incredibly effective in really finding out what your hobbies are based on the things that you read on the internet, and serving ads reflective of that. When it comes to clicks, I don't really believe generally that clicks are very useful. So I think the reality of clicks, I can easily get a factor of 10 on click-through rates. I just have to show on what I know to be fraudulent inventory where there is somebody else doing the clicking for me. But that's not really, that's not skill as far as I'm concerned.
So my question's for Yuan. So your data is a little bit different from the other two examples here in that you have some control over what your customers do. Perhaps not directly, but you can at least advise, and Dropbox obviously has a big voice in what it can ask customers to do through blogging, marketing, all of that. Do you ever use your suggestions to directly, I guess, try to change the behaviors of your customer? For instance, with the photos, to be able to organize them better by asking them to track, use folders and things like that?
Photos is actually something still in early stage, but there are similar things that may match your description. It's like, for example, sharing. If we push a new sharing feature, it does modify the behavior of the users, like to whom they share with and how often they share it. Because if we make sharing one click less easier, then they will share more. And also, if we make good suggestions, they would also share to maybe different or more people. Yeah.
Yeah.
A question on the basketball problem. You did say that there were certain pre-processing you had to do to get to the shape where you applied your model. There was some AR processes going on, some hidden Markov model stuff going on over there. So I was wondering as to how do you evaluate what the sensitivity of your model predictions are to those, that pre-modeling, if you like.
Right. So model evaluation is, I think, really important in any problem, but this one in particular, because there's so much sort of processing that's going on. So one of the ways that we're actually doing it, so for instance, the who's guarding who, one of the next phases of this project is using that to sort of assign attribution for sort of direct sort of equivalent to points, and to be points against. But that's a hard thing to measure because we don't actually have data on that. So we're actually doing some manual annotation. So we're actually going through looking at the actual video. The other thing that we're doing is sort of comparing the modeling to no modeling, in the sense of looking at just sort of standard posterior predictive checks. But in terms of comparing to the raw data, the best thing that we can do is to reference the video, because the data itself might have issues, but the actual, the video doesn't lie. So that's sort of the best strategy, I think, here, is to actually look at the raw data. In our case, we sort of have pre-processed data, but we can get to the raw data in sort of a weird way, which is to actually, watch ESPN.
Yeah, I have a question for all three speakers. Yeah, what skills do you think would be the most useful for students who want to work on these kinds of problems that are not necessarily emphasized in traditional stat and CS courses, other than conditional probability, of course?
I think there's an interesting quality to people that I'm looking for. I'm not sure if that qualifies as skill. There is a certain inherent skepticism at looking at data and not falling for what you seem to see there. And that's more of an attitude problem, that you are, very comfortable criticizing yourself and what you're doing. I think that's absolutely necessary because quality control is so inherently difficult. The other one is what I've seen. I've seen excellent statisticians and programmers who still have a hard time dealing with the practical uncertainty. They live in a deterministic world. I mean, you can be a great mathematician and prove the central limit theorem, which doesn't require a great mathematician, but I still can't do it. But that there is this thing about uncertainty in real data that some people thrive in and just do really, really well with, and others are more comfortable in the sorting world where either it's sorted or it's not and has kind of that binary. It's hard for me to put this in terms, but I've seen it occasionally, and when I see it, that's something I'd love to see in data scientists.
I think one thing I'll say sort of similar to Claudia's, and that working with data of this size and this quality, a crucial aspect is persistence. And because what you'll quite often see with this data is that, so in Jeff's talk earlier, he had these sort of, he showed the diagram going down from sort of seeing the data to having your end dissemination. I have a feeling like the bigger your data gets, the more loops you have going up, and the more sort of times you see that, because there's more and more things that go wrong with the data, whether it's misannotated in our case, or missing data, or it doesn't give you quite what you want. So the ability to see the big picture, so to be able to, when what you want to try doesn't break down, to sort of see, okay, here's the other options that we could take, and be able to quickly to sort of work around things. And that's a computational skill in terms of coding, but it's also sort of a higher level skill to be able to say, well, here's the problem, here's the first attempt that we had to try it. That sort of didn't work for this reason, what other options do I have? And so that goes also to this skill that's really valuable is someone that not just has like the raw statistical chops or the coding skills, it's someone who has sort of a breadth of knowledge that they can say, here's a problem, here's the data, here's not just how we're going to pursue it. Here's like 10 ways of how we could go forward. Okay, this, and this don't work for this reason. This doesn't work for this reason. Okay, we got 3 decent options. Let's talk about those. And I have a feeling most students would say, well, that's, we have a continuous outcome and a bunch of variables. Let's do regression. And that's not usually the right answer. It's quite often a good answer, but someone who can say, well, given all the limitations of the data, here's those options. And if you have that breadth, then you also have the ability to, if you get stuck, to quickly sort of work around it through alternative means.
Did you want to add anything?
I would say like communication and business insights, those are very important factors. And also ability to find problems with data. Like if you see a plot, you would instantly know there's a problem with the data, as well as a curiosity. We once had an intern that I liked a lot that he basically in 2 weeks, he himself just go out to identify problems to work on data problems. And so those are kind of curiosity you want to have in this kind of data scientist roles, who really likes this kind of projects, and they would go for it. And actually they have the ability to handle it in terms of engineering side and also data side to do analysis and also show the people that what it means.
Okay, so that concludes our panel and the day. So let's thank all our speakers again.
And also want to thank all of you for your tenacity, grit, and curiosity. So you're great data scientists in the making, or already are. So thanks again for coming, and see you at the next event.